And at a certain point, kind of mid-semester, she told me, now I understand what I want to do next. And I said, what is it? She said, I want to be a scientist. I want to pursue a Ph.D. degree. This was not something that I had initially in mind, but now I see the possibility, the opportunity, the power of these methods that I am learning to really help me pursue this field that I want, which is disease prevention, specifically the prevention of lupus, to help individuals that are highly vulnerable. That possibility of grasping, even before you grasp something and then you realize and you trust that that's possible, and therefore I want to spend my energy, my time in that, betting in that possibility.
I'm Brandon Vaidyanathan, and this is Beauty at Work, a podcast about how beauty works in our world and shapes the work that we do. This episode is sponsored by Templeton Religion Trust and the Institute for Advanced Catholic Studies at the University of Southern California. More about them later in the show. Hey everybody, I am so excited to welcome my guest today, Dr. Marcia Otto. She's an associate professor at the University of Texas Health Science Center in the Department of Epidemiology, Human Genetics, and Environmental Health. Marcia's research focuses on the effects of different aspects of diet on cardiometabolic health and cognition. Marcia holds a Ph.D. in environmental health from the University of Texas School of Public Health, and she received her postdoctoral training in nutritional and cardiovascular epidemiology at Harvard's T.C. Chan School of Public Health. Marcia's work has been funded by the National Institutes of Health, by the American Heart Association, and the Department of Defense. Marcia, thank you so much for taking the time for being with us today. It's such a pleasure to have you.
It's my pleasure. Thank you for inviting me.
Great. Well, let's start by talking about what drew you to become a scientist in the first place. Did you want to be a scientist when you were a kid?
I don't think I had a clear sense that I wanted to be a science, but I had a very big curiosity for mathematics and everything that involved calculations. I really enjoyed, I think I had, my dream job would be a job when I would be running calculations all day long.
Okay.
That's my early remembrance of my field of interest.
So how did you then pursue a scientific career? Did you have any, teachers or professors who were scientists? Like, what actually drew you to then see yourself as pursuing this path?
So I did have, as I was trying to understand what is it that I was going to study in college, I had to work full time. And so my first interest was to pursue engineering. I had friends who were engineers and I was fascinated. I liked the fact that you could use calculations to develop projects to obtain something concrete. And I also liked at that time, there was a big push for engineering in Brazil. So I knew there would be jobs. So I could do something that I was interested in, there would be jobs at the end of that tunnel, right? And so I started to look into engineering, but given my family circumstances, I needed to work full time. And so engineering classes in Brazil in public universities, which are the strongest universities, they were offered full time. So you would have to start in the morning and finish at the end of the day. And so I said, okay, let me think, what can I do to pursue my interest in mathematics? And so I thought about mathematics, and then I understood that physics was a field where you could learn mathematics and apply to understand problems, think about laws, universal laws, understand the world, basically. And so that's how I decided to pursue physics, following this little intuition. And I was admitted at the University of Rio de Janeiro, which is my hometown.
Okay. And so from physics, how did you end up in public health and epidemiology?
Yes. So As I began to study physics, and I remember, being interested in calculus and mathematics doesn't mean that it's easy, right? And so, as I mentioned, I was working full time from early in the morning until about 3 p.m., and then I would go straight to the university, and my course would be afternoon and evening, and I would leave at 10 p.m. Every day. And so I began to study a lot and study long hours. And by the mid of my midterm, around 2-3 years into the program, it was clear to me that, in physics, there is these two very specific branches. One is the theoretical physics, and the other one is applied physics. And usually theoretical physicists, they spend a lot of time understanding problems that are abstract, right? They spend a lot of time in this road where you think about the fifth dimension, things that are really difficult to study and grasp in reality. And I saw more and more the potential of physics to really help us understand concrete problems. And I found myself more and more interested in applied physics. I still remember my second to last semester, I had a teacher, she taught quantum mechanics. And she had just come back from a sabbatical because her grandmother had cancer. And she moved to this small town in Brazil where her grandmother was going to be treated. And she was a nuclear physicist. And she said, I want to be there with the physicians. Back then, cancer treatment in Brazil was very much, you would receive a very high dose, a lot of side effects. And the main goal was to make sure that you killed all the cells. And as a result, many organs at times were affected as well. There was not a lot of very specific, precise estimation of dose of radiation, for example. So she went there. Her grandmother was in her 80s. And the doctor said at first that there would be lots of side effects because of her age, and they were expecting her grandmother to have a difficult journey. So this teacher of mine moved there, and she spent the whole six months with the physician. She said, I am a nuclear physicist. I can help you calculate the dose for my grandmother for that specific case. And that she did. And her grandmother had minimum side effects. The whole treatment went much better than expected initially. And by the end of those 6 months, her grandmother had ended treatment and she came back to teach. And so the first day of class, she was telling us this, and she was also telling us how at the end of her grandmother's treatment, the doctors came to her and say, look, we need to work together. There is so much we can do. What you brought, the skill set that you brought was so valuable. And she said, no. I'm sorry, you don't understand. I'm here because of my grandmother. I am a theoretical physicist. I am not interested in anything that is concrete. I like my field and interest is to really do theoretical physics. And she's telling us in the classroom with her eyes super satisfied with her answer, right, to the doctors. And I looked at her and I said, wow, that is not what I want to go. I do not want to be a theoretical physicist. If that is what the field entails, I want to. So her whole experience and her excitement in having helped her grandmother helped me clarify that I really wanted to pursue something that was more applicable, a science that could be used to help society, to help individuals, and so on. And so I finished the only intuition that I had at the end of my college was that I wanted to pursue applied physics. And I had some research experience on nuclear physics. So by the end of college, it was clear to me that working full-time and studying full-time was too hard. So if I wanted to pursue a graduate degree, I wanted to apply for scholarships so that I did not have to work. And so I applied to a couple of programs in Brazil, and one of them was a program that was evaluating environmental science, which was a big growing field back in the early 2000s. This program would bring professionals from different areas to study the increasing problems of the environment. And so I applied to that program. I was very fortunate to obtain a full scholarship, and I was there being trained in nuclear physics applied to environmental problems. So I would come from the physics angle. I would be working with engineers, sociologists, architects, people working with different environmental problems. And I would have a strong physics training and then apply that to the problems of the environment. And so in that program, I became more and more aware that lead in water was a very big problem, especially in poor communities outside of Sao Paulo city, in which I now resided. And so my theoretical problem was to derive equations to estimate the intake or absorption of lead in biological samples. So that was the project for my master's training. And so as I was part of that program, I was studying water pollution, I was studying air pollution, I was involved in large discussions about environmental problems in Brazil. And so I understood in my studies that individuals who were at highest vulnerability to health problems due to lead exposure were children. So their brain is under development, right? And what happens with lead exposure is that it attacks the neurons. And so children undergoing neurological development, they were more vulnerable to that exposure early on. And so I defined a study. I said, okay, I want to study, if I am to quantify, I want to quantify exposure in children in certain regions in Brazil where they are at higher risk of lead exposure. The second thing that I learned was that bone structure is the place where lead is stored in the body. And because I was interested in children, I also understood that teeth, like milk teeth, would be a great indicator, a great sample to obtain to measure and quantify lead exposure that would occur in childhood and therefore be more relevant to long-term health consequences. So I developed my whole model using teeth as a biological sample. And then I would go to the lab. So I went to dental clinics in the outskirts of Sao Paulo city to collect teeth that children would be having removed in those clinics. And that I used in the lab to quantify lead and with the whole estimation of how much they were being exposed. And I also went to a different group of children who were less exposed to lead because of the water sources, and I compared those two groups. At the end of my master's training, when I was defending my thesis, I was told that they needed to find an epidemiologist to be part of my evaluating committee because the work that I had conducted was a pure epidemiologic study. And that was the first time that I heard that word.
That's great.
And so it was very clear to me that I wanted to learn those methods. I wanted to pursue that path. And that's how I ended up applying for a Ph.D. program in epidemiology here at the University of Texas, and then moved to the United States.
Wow, that's really fascinating. And you've stayed with it since then. Have you found it satisfying as your journey has continued in this path?
Yes, it's such an adventure, Brandon, when you begin to follow a glimpse of an interest and very closely. I was reading your work and seeing the videos that you have put together on beauty, right? And I have recognized one by one this beauty of understanding has been really very, very striking to me. So when I arrived at the University of Texas, there was a large program in environmental health. The department was being restructured. There was not a lot of scientific projects on heavy metals and effects on health, which was my primary interest. But then I was very early on introduced to a professor who was doing work on diet and the effects of diet on heart disease and chronic diseases. And I explained to her my work and my passion to understanding especially effects of heavy metals on health outcomes. And she said, I do not have any project on heavy metals, but I do study essential metals. Would that be of interest to you? And just like that, I said, of course, that would be of great interest, because it's exactly in the absence of good nutrition and in the absence of essential metals that those heavy metals become even more dangerous, because the human body is so fascinating that it uses everything it has to do the work, right? So neurons, in the absence of calcium, which is a very important essential metal for the brain, the body would use any heavy metal that we find. And so that's how I shifted to nutritional epidemiology, and the adventure began, right? Now I have a whole new world to explore, to understand, to really focus on in order to get to a final goal, which was really to help society, to help shift the health of populations.
Yeah. That's amazing. Talk to us about like the beauty you experience in your work today. What does that look like for you?
Yeah, it's a great provocation, because as a scientist, it's not that I go to work and I say, okay, today I'm going to look for beauty, right? But again, in becoming more familiar with your work, I quickly understood that it is these moments in which we grasp something, in which we the whole process of being able to grasp, to understand, we human beings, limited beings, how is it possible that we can move from a curiosity or a broad interest in a certain problem and then refine that research question, right? Think about which metrics will be needed in order to evaluate that research question, define a method, understand the statistics or what is it that will take to address that question, all that step-by-step components all the way until we actually are able to see something. The whole process of being able to understand, to me, is fascinating. And that's exactly what I teach. So there are two super important components. First, I see myself designing a project, evaluating, going to the communities, collecting data, spending the time in front of the data, doing the data analysis, and then seeing something coming out of that process, right? That allows me to understand at a different, deeper level. And then at the same time, I am now teaching these methods, and I am seeing students undergoing the very same process, which is coming with an initial interest, being able to walk that path, especially understanding the methods and designing methods that will allow them to explore and address a particular research question. This has been fascinating to see some of the vibration that I experience in my research also in front of me in the classroom.
Yeah, what is that? How do you recognize that in the classroom? What does that look like when when you're able to see your research interest or the understanding that you find beautiful in science resonating with someone else? How do you glimpse that?
So I had this past semester in the fall, I was teaching an elective course called Nutritional Epidemiology. And so in that class, I bring my research, I bring others' research, and the idea is to just let's look at these studies. Let's understand what is being proposed in terms of research question, what was the methodology that they used, and what they found out. And one by one, this is an elective course, it's a small class. Last time I had about 16 students. And it's a new course for me, so I'm still exploring how is it that I present content and provoke students to think about methodology, right? And I had I'll tell you about two specific students. So I had student A and student B. And student A is the third semester master student, and he comes to the classroom slightly late every day, and he sits there and he's distracted, right? You can tell that this class starts at 10, he's very distracted, he's still landing and so on. And later I understood that he's constantly late because he works at night. He works at long hours at HEB to provide for himself while he's pursuing his degree. So student A is there, sitting there, has very, very curious student. He's very also interested in statistics, so he has studied lots of statistical methods. And we are there looking at his research, nutritional research. Day after day, I see student A waking up in front of the screen and starting to ask questions, question after question after question. And he's also started to wait for me after class and continue that conversation. And at one day he told me, I've been taking all these different courses, and I really love biostatistics, but I never understood how those methods were used to allow us to understand this piece of reality the way that you were explaining. I never saw the need, for example, for how a p-value could point to a particular path in which that mechanism is now something that we can explore further. And the moment I could see him becoming more engaged in the classroom, asking more questions, more excited because he saw a pathway through which his own interests and training could lead to a new direction, right? And I was extremely pleased because that's exactly what happens to me. It's contagious when you see that vibration of, okay, first of all, it's possible for me to understand something, and look at how much I can see now, right? That was phenomenal.
Wow. You said you had a second student?
Yes, my second student, I'll call her student X, and she is also very, very young. She's actually at her last semester, and she's still seeking, right? Students who come to the School of Public Health, they want to save the world. They don't want to be rich necessarily. They really want to do something that matters for society. And so she comes with a general interest in public health because she has a health condition herself. And she always wanted to understand, if I am to contribute to the prevention of this health condition, I would like that. And if public health is a field that I can pursue, that's what I want to do. So she's finishing her master's degree. She still hasn't really understood what she's coming next for her. And she's sitting there at my class. And again, I see her starting to ask more and more questions. I see her level of engagement. And at a certain point, kind of mid-semester, she told me, now I understand what I want to do next. And I said, what is it? She said, I want to be a scientist. I want to pursue a Ph.D. degree. This was not something that I had initially in mind, but now I see the possibility, the opportunity, the power of these methods that I am learning to really help me pursue this field that I want, which is disease prevention, specifically the prevention of lupus, to help individuals that are highly vulnerable. That possibility of grasping, even before you grasp something and then you realize and you trust that that's possible, and therefore I want to spend my energy, my time in that, betting in that possibility.
Could you say a bit about the relationship between grasping this sort of beauty of understanding, right, having a scientific sort of insight, and then the usefulness of science for helping other people? Because certainly people find the beauty of understanding in theoretical physics, right? So by itself, understanding is highly pleasurable for a lot of people, but it wasn't good enough for you, to like, you needed something more, and it seems like there are a lot of students in more applied fields who need something. Um, uh, so is science beautiful because of the value it has for society, or does it have its own sort of intrinsic value, or how do you see that?
I think I will start with back to that possibility to know, right? I first heard that from a friend who is a theoretical physicist. And I was back then like an early stage graduate student. I was overwhelmed by the complexity of things. And the more I studied, the more complex it looked to me, right? And one day I was just giving him a ride, and he was senior, very excited, living scientific life as an adventure, right? Not as something very difficult, but as something full of possibility. And I remember asking him this question: how is it for you? Is it that easy? Is it exciting? Because how is it? Or how is it that you are not crushed or overwhelmed by the complexity? And he looked at me and said, I am excited because just the fact that it's possible for us to know, it's almost a miracle. This could remain kind of unveiled, right? And yet, at times, something happens and you can see through and you can see more. And that alone makes me live life full of possibility. And that, I think, is the beauty of science, even before it's how you apply, which problem you apply, etc. Right? It is the possibility to know, which is not a wishful thinking. It's an experience.
Right. So the usefulness is like an added bonus, as it were. I mean, the fact that not only can you know, but then you can use this knowledge to improve things and help people and
So beauty is almost like a companion on the road, right? If I think about myself and my experience, I started with a very intuition, like an intuition that I wanted to study anything related to numbers, loved numbers. Didn't see any use for it, but I loved numbers. And so then one by one, I was exposed to so many things in college. And then finally, this teacher's experience that really allowed me to see it more clearly. Okay, I know that I want to do something that is applied, but I don't know exactly what. And look at this possibility here. Look at what she's done. Look at how much more could be done, right? So I understand that within myself, I had a desire to use that curiosity to something good. And so want to get, I think I see that in my students too. We all want to find our talent and to use it well. And so it was a combination of me trying to find my talent and use it well with my teacher's experience, and then the enthusiasm that comes when you see a new journey opening up, or a possibility of a journey opening up ahead, right? That's where beauty takes place, because when you see that can be a possibility for me, I immediately want to take it. And then that process continues, right? That seeking, that finding, the surprises that come along the way. All of a sudden, I found myself not being so much overwhelmed by the difficulty and the challenges, but excited at the possibility.
that's great. What is it like for you right now as I mean, you're a, tenured professor at a university, and a lot of faculty face a lot of pressures, institutional pressures to publish or perish and to get grant funding, etc. And so we've talked to a lot of scientists in that position who feel like the wonder and beauty that drew them to become scientists in the first place is somehow out of reach because of all of these pressures that they kind of overshadow um, the sort of joy of science. And I wonder if you've experienced anything like that, or how you navigate this sort of context.
Yeah, no, I for sure experienced that too. We all need to be publishing, we need to be teaching, we need to be doing research, we need to be writing grants, right? All of it is a lot in itself. For me to publish, one of the things that I love the most about science is that I can study, I can test possibilities, I can understand and study a particular method that will allow me to in a very sophisticated way, explore a research question. And all of it at times is expedited because we need to publish a paper, because we need to rush to meet a grant deadline. And that's when, the whole joy sometimes can be, we may not enjoy as much, because what we love the most, what I love the most, perhaps I do not have enough time to stay in that position. And recently I was exploring different research possibilities. There was, as we all know, this huge COVID pandemic, and I was asked with other colleagues to join a task force to help guide public health action in the state of Texas, in Harris County. as part of the response to the pandemic. And that was a deviation from my field, which I dedicated time to very passionately, because I thought this is my chance to help, right? With this, provide some little help in this to this big problem. But then here is what I understand more and more about the pressure of work, and it's in science and it's everywhere. We are pressured to deliver. But once we are attracted and moved by something, by beauty, let's say, right? I am using beauty here, but it's something that I cannot quite quantify. But once that dynamic takes place that I was mentioning before, right? We do not want to do for less. So the question of, how many papers, very often I find myself longing for those moments of beauty that come when I stay in front of my problem with a little longer, when I have more time to brainstorm with my colleagues, when I have more time to brainstorm with my research team, right? When we are allowing ourselves to explore some possibilities, that longing is there, quite kind of calling me back to a position in which I'm just not only having to publish all these manuscripts in a year, but I'm here because I've been, in a way, moved, and I want to be moved again. I don't know if I am quite fully getting to the core of your question, but what helps me is to have that experience of grasping a little bit more of reality, right? And when I find myself in a place where I'm not growing, where I am not learning, where I am not providing my best contribution to my work, to my students, immediately a sadness comes to place. And I have to rediscover within this new world and all this pressure, what is really moving me right now. Does that make sense, Brandon?
Yeah, I think
Ask
so.
me more questions.
Yeah, no, I think
free.
that's the so for me it's I'm trying to understand what it is in the face of these challenges to remain energized, remain engaged, to not be overwhelmed by the pressure, right? And so what is it that you're looking for in these when you're trying to navigate your way through this? And I mean, maybe another way to get at this perhaps is what advice would you have for colleagues who are struggling to find beauty in their work?
I would say do not forget your heart, your passion. Do not forget that initial impetus, right? If I forget, like recently, I started talking about a different research path, but I started doing a work that was a great contribution, but not necessarily my greatest passion. And after a while, as my research, I began to explore in a project on cancer patients. It's incredible how, I had not connected the dots until right now, but I'm looking at a new project evaluating nutritional deficiencies of a certain group of cancer patients. And that project is in collaboration with clinicians who are very passionate in helping their patients. They say, we know that there is a dietary component that is essential here. We don't know how it works and we would love to work with you. And so I'm seeing these clinicians who are seeing these patients, and they have a very clear idea of what the critical questions are. And we are collaborating and designing this project, and I began to be again reignited by these key elements, right? We are all made with the desire to find our talent and to use it well. So I found that whole thing reignited in the relationship with these clinicians. And then immediately at the same time, I have many other pressures. But because I have experienced this excitement before, I said, look, I think there is a road here that I want to pursue. And this is perhaps my advice, is that we are never quiet. Let's never be quiet. And there are many times in which we are under a lot of pressure and constantly under pressure. But I am reawakened somehow by this continuous search, right? This research of what is it that I can contribute the most at this very moment. And the more I discover, the more I remember that initial passion, the more I know what's the way for me. That doesn't take away the number of papers, that doesn't take away the pressure that we receive, but as long as I am moved by the sense of the truth of my path, then I can breathe and I can find ways to meet those goals, right? But with my heart kind of centered in the best position, if that makes sense.
Yeah, I mean, I think I was struck by the desire to contribute that seems to really animate you, and I think there's an interesting danger for a lot of people who are seeking fulfillment in their work, who are looking for something, right? So you could pursue beauty in a way that you're looking for it as something that you consume. And if it's not there, then you feel like, well, then I need to do something else because I no longer find this fulfillment. But I suppose if you're looking to contribute, and you're trying to see where can I give the most of myself, and make the best contribution, I think that orients you in a different way, and perhaps opens you up to finding beauty in surprising ways that perhaps if you were simply saying, this is what I think of as beauty and I'm going to look for it, and if you don't find it, you're not fulfilled. I mean, that could be a distracting a sort of pursuit, I suppose. I don't know if that resonates at all with you.
Absolutely. I think that openness is key, right? Openness to discover what is my curiosity about, like what is it that allows one to get out of their mind. I have several ideas, right? I have so many things going on in my mind, and my own idea of, for example, how my class would go, how my interaction with the students would go, how clear my lecture would go. And then I go there, and many times it doesn't quite work. But I've been more and more surprised at what is it that allows me to be open to even something that seems not to be working. And to me, in my teaching, is by looking at the faces of my students, and then following that, right? So, okay, wait a second, I can tell that you have a question. What's your question? And at times I shift the entire lecture to address that question and to follow what is it that is triggering that student. The question of openness is really crucial, and what allows us, Brandon, maybe I have this question for you. In your conversations with many scientists, what is your intuition of what allows us to be open to this road ahead, as opposed to me trying to trace or to make my journey, and this I'm sticking to it, right?
Yeah.
As opposed to trying to navigate and adjust and adapt and be open to what the road is showing itself.
That's a really great question, and I don't know if I have a great answer for it. We do see those differences. I think there are some certainly who have that sense of open. I think in part, the scientific community, I think, seems to cultivate this kind of intellectual humility and openness to surprises in many many fields. I think that's the case. But I have heard that there are not just individuals, but entire subfields where they're kind of locked in to a particular looking for a particular kind of beautiful theory, um, and not really open to things that might you know unsettle that. Um, I think it's sometimes it's an overconfidence that successes of the past will be repeated in the future. Um, I I'm not entirely sure what leads one to be open to those surprises, and maybe impatience might lead people to be open to surprises and say, look, we're trying this, it's not working, let's move on. Maybe a lot of patience and perseverance might not be an asset because it might keep you locked in
That's
and say,
right.
no, I'm going to, there are a lot of famous examples, and particularly in theoretical physics, of scientists who said, I'm going to stick to my beautiful equations, and even if the experiments today are not supporting those equations, you'll see. And some of them turned out to be right, that the experiments were wrong.
That's right.
And
That's
so
right.
that provides a strange kind of historical precedent that I think leaves people justified. But I wonder in fields like yours, when there's people's lives at stake, I think maybe there's more of a need to say, look, we need to really do something because the problem is really urgent. We have to be open and we have to try different things. I don't know. But that's something for us to explore. I don't think we have a good answer. Um, no, it's a really great question on sort of science as sort of this is the constant tension between basic and applied sciences as to should is science valuable because it's useful to society and because it solves our problems, or is science valuable because we need to understand reality, and who knows what that understanding will produce in the future. Maybe the problems that seem kind of useless to pursue today might lead to breakthrough discoveries, 100 or 200 years into the future. And how do we invest resources, right, as a society, into those different kinds of pursuits? Those are tough questions, I think, for us all to ponder.
Very, very tough questions, and I'm happy because there are different branches of science that are dealing with these questions in different ways, right? In public health, and I go through textbook after textbook for my classes, and I see more and more now going back to it as a teacher, that there is this push for science that leads to action, because because lives are at stake, right? And it's not necessarily one thing or another, but in this branch, we are seeing an increase, a tremendous increase in mortality due to cardiovascular disease. And that is one of or one of my students who is seeing the huge gap in knowledge in lupus. What are the factors that could help prevent? So the questions that arise are really uh, uh, impact. The questions arise within the context of this practical problem, right? And then the science helps, and then we make mistakes and so on and so forth. But that is the first thing that strikes me is the size of a certain problem. Some of the physicists started, their problem was different. They wanted to understand a universal law that would explain a certain process, right? And that's a beautiful thing to explore too. So starting with the question, I do think that there is not one or another. I think there is a big value of applying methods that we already know, while others will be thinking the unthinkable and helping us move that thought process or the science further, right?
Yeah. Well, let me ask you one last question that has been, I think, troubling a lot of people, which is the question of the public's trust in science and in scientists, particularly in the United States. I mean, since the COVID-19 pandemic has, been, um, I think an interesting case in point. I think there are a lot of people who are troubled by the fact that scientists seemed to say something on one day and change their minds and say something else the next day and so forth. And it seems as though the public has this picture of science as being able to provide definitive facts, right? That this is um, that it's sort of infallible. And the beauty of facts is actually what, for a lot of people, draws them to say, "I believe in science," as though it's this sort of religion of sorts, right? It sort of seems to have a sort of dogma where it pronounces some truths and then people have to believe it. And a lot of scientists don't really like that kind of image of science that has been communicated. And I think in particular in fields like public health, it's really critical to figure out, well, how do you, once you know something to the best of your knowledge and there's some degree of consensus, how do you communicate that in ways that still um, allow you to continue investigating, and then perhaps you could realize, gosh, okay, everything we prescribed is wrong, and we really need to redo things. How do you do that? How do you navigate that kind of field and interface with the public? Or what is it that maybe you want the public to understand about your work as a scientist, and when the beauty of that kind of scientific work?
Yeah, well, as much as I think in certain branches, especially in public health, we are urged to respond to an urgent need, right? If I think about my recent interactions with public health practitioners who needed to know at this moment, what are the communities at higher risk of infections that we should go and send testing units to and later on prioritize for vaccination, right? There is a question that is today, we are making a plan for tomorrow. What's the best way to use the data that we have to guide our units, to guide our action? And this is really part of a practical public health in action kind of scenario. But what I tell my students, and I study a lot of chronic disease, what are the risk factors for chronic disease, how certain risk factors really impact development of cognitive decline, heart disease, diabetes. And the road to that understanding is a long road. We began by exploring a particular mechanism. We began by exploring this size of a problem, right? But very often, the way that those findings are communicated, they are communicated in a way that, number one, expand too much of the conclusions from that particular study, right? And it's a whole field of, it's not only the scientists that may communicate in that way, but many times it's reported in that way because everybody's looking for answers, right? But the road is long, and we need several studies to allow us to become more confident, and perhaps at times we are not confident at all. We need to develop new methods, we need to develop new metrics, we need to wait more and see. So having that caution and putting the findings in perspective, it's an extremely important thing, because science for sure brings a lot of value, but science is not the final answer, right? Especially for complex problems. We need to be able to, not one scientific finding, not one particular study, and very much at times findings from one study are communicated as if this is final. We now know how saturated fat affects the heart disease risk in adult populations. So I would certainly stay away from definitive answers. We move by becoming more certain based on replication based on understanding, okay, if I find the same answer in a different population and with a different composition, a different type of diet, so I am moving to become more confident, and yet there are so many limitations, right?
Yeah, and I suppose that's the challenge is how to preserve this sort of confidence and uh, trust in science in the face of the fact that we are so limited, right? That our knowledge is always provisional, um, and that I think is really the daunting task for a lot of people.
Yeah, and I always tell my students, we epidemiologists, I say we are never afraid of limitations, but we take a lot of time to understand what we are doing, what are the limitations of what we are doing, and reporting and discussing it very carefully, being very clear as to what is it that we can see a little bit ahead based on these findings, and what is all of it, all of the questions that are opening up as part of this process. Being very clear and transparent as to what we can say and what we cannot. This is what I encourage my students a lot, and this is what I try to practice when reporting my science.
Right. Yeah, we had one of my recent guests, also a Brazilian scientist who I interviewed recently, who talked about how the limits of science or the limits of our knowledge um, are not really a bad thing because we'll never really arrive at fully knowing, and that's a beautiful thing. That there's always going to be more to know and more to understand, and our knowledge is always improving. And we should see that as liberating as opposed to burdensome, which I thought was really, really quite beautiful.
I fully agree. And what I observed with my students, especially coming out of the COVID era, was that they arrive in the classroom and they are reading those papers and studying the science, and at the end they would say, but we will never know because the studies are so biased. So the coin had flipped to the point that instead of there is a possibility to know, now we will never know. There is bias, there are not enough individuals from certain groups. So there were all these criticisms to the studies that left them with a sense that no study could help us understand anything because you have all these sources of bias. And yet we can't. There is the possibility of learning, right? Not learning at all. We were not going to solve the entire equation, but the possibility of knowing is also extremely liberating. As long as we understand the limitations, we study very well, we design this most possible strong study, and then we report it clearly, honestly, especially in what is it that we do not know.
Yeah, great. Well, Marcia, thank you so much. This has been such a rich conversation. I'm so delighted that you were able to join us. And where can we direct our viewers and listeners to your work? Where can they learn more about what you do?
Yes, so we have a site in construction, but if you go to UTHealth, uthealth.tmc.edu, you will find my page there and my research interests and projects.
Perfect. Well, we'll link all those in the show notes. Thank you, Marcia. Such a pleasure.
Thank you. It's my pleasure, Brandon.
Hey everyone, thanks for watching. If you liked that video, please hit that thumbs up button and share it with your friends. Also, please take a second to hit the subscribe button because it really helps us out. Thanks.